So in this unit, we're going to start by simplifying trigonometric expressions. We lost 2 days this past week, which means I've had to cut some material out. Our goal is to test next week, Thursday. That's the day that the administration has said is your final exam. So that was not a date I chose. They said math is on Thursday. Some other subjects are on Friday. So we will do Thursday. We'll get in what we can by that time. You'll get a study guide. You'll get a day of work ahead of time. We need to keep pace in between. Ready? We start with even and odd identities. So notice how I have sine, cosine, and tangents, but they have negative angles, right? First thing you're going to learn today is we don't leave negative angles. We don't. We see what happens to these negative angles. Sometimes they disappear. Sometimes they move out front. And they have to do with what we call even and odd identities. Now, try to reference your memory. Does anybody remember when we plugged in, anybody remember when we plugged in a negative x and sometimes we came out with negative f of x? And other times we plugged in a negative x and we just came out with f of x. First semester we did this negative x testing stuff. Remember a little bit? Like you plug in a negative and you see what happens. Sometimes it showed that they were odd functions. An odd function would be like x cubed. Notice how it's symmetrical about the origin. Like if you spin it 180 degrees, you get the same thing. Whereas for an even function right here, if you take the graph of y equals x squared and you spin that around the y-axis, you get the same thing. So those are even, those are odd. That's something we talked about once upon a time. Okay. Notice with odd functions, the negative pops out front. With even functions, the negative is able to just disappear. Well, it turns out that if you graph sine, it is an odd function because it can be spun around the origin. Whereas if you graph cosine, cosine is even because it can be spun about the y-axis. So therefore, we say that cosine is even and sine is odd. So if sine is odd, what happens to the negative? Moves out front, negative sine of theta. And the same thing will happen with cosecant. Cosine and secant, what happens to the negative? It disappears because they are even. So you get just cosine of theta and secant of theta. Yeah. Nope. And tangent of a negative, tangent is very similar to the x cubed function, so it is odd. So you get negative tangent of theta and negative cotangent of theta. Think you could remember those? Okay. It's to your benefit to remember them. But the reality is I know a lot of people don't, so I produced this sheet for you that is going to have, at the end, you get to use this on the test. And right now we just covered the even and odd identities. We'll be covering all these formulas during this unit. You need to know where to reference them, okay? And so there they are. I really felt like it was important for me to remember them. So I remember in high school, my teacher said, you guys get to use a sheet of notes. And I said, I'm going to just do it on my own because I want it to be locked up there. Some of you guys may think that that's funny. There's a big difference between people who always have to look at the sheet all the time and people who don't. Now, I'm not saying you can't have it there as a help, but the more you understand these things, trust me, the better off you're going to be. I've seen it way too many times. And if you'd like the challenge of going without the sheet, awesome. Nobody's taken it up on me in 15 years. I'm waiting for one. Caden, you look ready. He's thinking about it. Okay. So you've learned about the negatives. Now let's learn about writing things in terms of sine of theta and cosine of theta. As we simplify trigonometric expressions, there are many ways that we can do so and strategies that we can use. The first strategy is to write in terms of sine and cosine. And here's what I mean. If I look back to the last page, I see this thing sitting there. It says trigonometric identities. And these are things that you already know. you know that tangent is the same thing as sine divided by cosine, don't you? And you know that cosecant is 1 over sine. We've talked about that. And secant is 1 over cosine. And cotangent is cosine over sine. I give those to you. We don't really use this side very much, but we use this a lot. It will be to your benefit to never have to look at these. These are super important to try to always know. It's going to help you out a lot. If you'd like to rip it off right now and use it as we move forward, go ahead. What's nice about these is that they are all written in terms of sine and cosine. So watch what happens. I have the following. I have sine times secant. I'm not going to change sine because it's already in terms of sine and cosine. But secant, I'm going to rewrite as what? Anybody know? 1 over cosine. So when I multiply them together, what do you get? Sine of theta over cosine of theta. And some people might say, well, I'm done. But as Erin recognizes, she knows her identities, and she knows that sine over cosine is the same thing as. So the answer is tangent of theta. Kind of weird, huh? You're used to taking, like, say, 3 times 4 is 12. Now you're taking sine times secant as tangent. But it's it works out. The next one, how would I rewrite cotangent? I'm going to write in terms of sine and cosine, not tangent. Cosine of theta over sine of theta times sine of theta over 1. What are you left with? Cosine of theta. So cotangent, I chose to use this one right here. So cotangent is cosine over sine. Yes? Oh, you're going to flip the page. There you go. Yep. So cotangent is cosine over sine. And then sine, I don't have to switch because it's already written as sine. Look at your next one. We're going to skip C and we're going to move on to D. How would you rewrite cotangent? Cosine over sine. We just did that, so that was good. That's kind of something we remember. How do you rewrite secant? 1 over cosine. Good. So Kenny sees 2 things. Number 1, he sees that the cosines cancel, and you're left with 1 over sine. And what is 1 over sine? Cosecant. Try letter E on your own. Nothing cancels and nothing simplifies. It's simplified from the beginning. It is secant, cosecant. It is the answer. Yep. Okay, you should have sine of theta over cosine of theta times 1 over sine of theta. Notice that the sines cancel. 1 over cosine is secant of theta. There you have it. We're going to skip letter F. We're going to move on to letter G. What's different about G? You have negatives and you have division. Okay? So let's first deal with the negative. What do you do with the negative when it's inside tangent? The negative comes to the outside. Negative tangent of theta. And secant of negative theta, what happens to the negative for secant? It disappears mysteriously. Where did it go? Will we ever get it back? And now we can simplify. What's important is you rewrite negative tangent. We're going to write it as negative sine of theta over cosine. it's not negative sine over negative cosine. You just make either the top or the bottom negative. It's just one negative, okay? And then divided by what on the bottom? Which is 1 over cosine. So I don't divide fractions. I multiply by the reciprocal. And notice that when you multiply by cosine of theta over 1, what happens? The cosines are gone, and you're left with negative sign. Try letter H on your own. You okay, ZZ? Got cold? Okay. No, you want the goal is to write it so it always has sine or cosine in it. So if you rewrote it like that, then the sign is gone. You don't have to rewrite everything. You don't ever rewrite sine or cosine. You rewrite the other things. Okay, you should have 1 over sine divided by cosine over sine. Notice that when you multiply by the reciprocal, sine of theta over cosine of theta, that the cosines cancel and you get secant. We good? It is helpful if you know your identities so you can anticipate what's going to happen. Watch how I try to think ahead here a little bit as I look at this next expression. Because when I look at this, I see the answer right away. I see the answer is 1. And you might be like, well, Mr. Gens, that's because you've done the problem before. Yeah, but let me show you how you can see it too, really quickly. I have sine over 1 times, what is secant? 1 over cosine. And it's just by seeing that secant is 1 over cosine that I can see the answer is 1. Because what do you get on the top? Everybody see tangents on top? And what do you have on the bottom? You have tangent on the bottom, or sine over cosine. And so you can see that produces 1. So trying to look a little bit of ahead and anticipate is helpful. There's lots of roads you can go down. We're just dealing with one right now, but lots of things you can do. Okay. All right, we're going to skip J. Try letter K on your own. So it's 1 over sine over and then cosine over sine. And now multiply by your reciprocal. So this one, you're going to take the reciprocal. So sine on top. There you go. Notice that the sines cancel. And 1 over cosine is secant. Hopefully when you did this, you noticed that the sine squared canceled both of those and left you with just the cosine in the top. Is that your question?
Yeah, I just want to double check that.
Sure. So for letter L, this is straight from an ACT question. And I really, really like it because it's really a very, very simple question. But it looks complicated. Like if you would walk into class right now, you'd say like, well, how do you even begin? Right? But we're just going to use our properties. We have tangent of x plus, what is this going to be? Just cosine. And then what's this going to be? Minus tangent. The tangents cancel, leaving you with just cosine. Not difficult at all, right? No. All right. We'll do 5 more. So there are about 4 levels to these type of problems. You are at level 1. We're currently investigating the easiest type of problems, okay? We have challenging ones to get to. The second method that you're going to look at for simplifying is to substitute identities. So the first thing you could do is you could rewrite in terms of sine and cosine. The second thing you can do is substitute identities. I can't tell you what to do when. You remember the last test I gave you guys a decision tree? I mean, like you followed that thing, you're going to be golden, right? I can't do that for you here. You got to look at options and choose one that's going to result to the right path. And I can't tell you the right one. You got to be willing to investigate and try. So I look at this one right here. A lot of people, they like to distribute right away, which is an absolutely horrible idea. Now you're like, well, why would that be a horrible idea? Well, try it. You're not going to get anything good. Promise you. And that's why we're going to do a different option. We're going to substitute an identity. You're like, well, what's an identity, Mr. Gins? I'll show you. Super simple. You guys all remember, because we talked about it and how important it was, what's the most important formula in all of trigonometry? Great. A squared plus b squared equals c squared. And we use that to come up with a trigonometric formula. What was it? Very similar to a squared plus b squared or c squared. Nope. 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 Sine squared plus cosine squared is equal to 1. That was the most important formula. You used it many times on your first test, third quarter. Is it amazing what we forget? Yeah. So let's look at that. If you look at one of your pages, we'll look at this one right here. Notice that down here I have these important formulas listed out for you and some of the things that we produce from them. So in your first one right here, it says sine squared plus cosine squared is 1. But from that, we can produce other formulas. For example, suppose I subtracted a sine squared from both sides. I would get a cosine squared is equal to 1 minus sine squared. See that? In fact, I even did that for you over here so you could see that that was another formula you could come up with. And right here, you could also subtract cosine squared from both sides and say sine squared of x is equal to 1 minus cosine squared of x, which is right here. So anytime you see a 1 and a squared, there's a good chance that it's sitting on this sheet and that you can make use of it. These are a couple that you really want to try to remember. They get used a lot. So if we look back at this, when I see this, I don't try to distribute because right away I recognize that 1 minus cosine squared is what? Sine squared. So this thing produces sine squared times cosecant. Well, now the problem becomes really easy because I've seen that before. That was like on the front page of our notes. All I have to do there is write it as sine squared over 1 times 1 over sine. Knock off one of the sines, and you get sine of theta. That's the result. Look at the next one. Oh, I see a secant squared and a minus 1. That's got to be something on a sheet. It's got a squared and a 1. Secant squared minus 1. It looks like this one has a secant squared and a 1 in it. So yeah, if you subtract a 1 from both sides, you would get tangent squared is secant squared minus 1 right here. Look at that. So I could go ahead and grab that guy. I've got cosine squared of theta times what? Tangent squared. And I'll rewrite it as cosine squared of theta over 1 times sine squared over cosine squared. And what happens? Letter O. I see a secant squared minus 1 on the top. We just talked about that. What's secant squared minus 1? Now you have tangent squared again. Over sine squared. How do I do that? Sine squared over 1. So you're going to multiply by the reciprocal. Sine squareds cancel, leaving me with 1 over cosine squared, which is secant squared. I don't like to hold you late, but I really would like to do these last two. I don't want to do this one, but I like to do P and Q. It'd be really helpful for you as you look towards your assignment. Yeah, a lot of times people like to do this and just like we're done. That's totally illegal, okay? So I'm going to rewrite it like this for your benefit. Suppose it was x squared minus x squared y squared. You would never just cancel out those x squareds, would you? But you could factor something out, couldn't you? And so factoring is a third option that we use. If I factor out an x squared, what are you left with?
No, 1.
1 minus y squared. That's how that factors. So what can you factor out here? And what are you left with? That's awesome because I know what 1 minus sine squared is. What is it? So I get tangent squared times cosine squared. Now that's the same as a problem we did on the front. I take sine squared over cosine squared times cosine squared over 1. And what do you get? Sine squared. Please stay with me. The one last problem. Won't keep you too late. What do you factor out of r? Cosine squared. When you factor it out, what are you left with? One plus tangent squared. What is 1 plus tangent squared? It is secant squared. And sometimes you then don't even need to rewrite it. What is the relationship between cosine and secant? Don't say they're opposites. They are reciprocals. What happens if you multiply two reciprocals? You get 1. So in your homework, there's problems that would be good to try and problems that are not good to try on your first page. On the first page, I would not try 7 and 11. I would not try 7 and 11. I would save those for tomorrow. On the second page, I would try 13, 18, and 21. 13, 18, and 21. Those would be good problems, okay? I would. Thank you for your patience. Nope, 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 nope.